All right, the next one says find the derivative, express your answer with a common denominator. Sorry. So this problem, we need to remember the product rule as well as the chain rule. So the product rule, if you take the derivative, let's do this in blue, that derivative is going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. So there's your product rule. I like to think of it as first times the derivative of the second, and then plus the second times the derivative of the first. And those orders, it doesn't matter the order. The quotient rule, the order matters, and product rule, order doesn't matter. And then we also need to think about the chain rule. We want to take the derivative of a composite function. Then remember, to do that, you're going to take the derivative of the outside function first. So this will be f prime of g of x times the derivative of the inside, so g prime of x. All right, the first thing I want to do is take this function and rewrite it just a little differently. Anytime I have a radical in a function that I'm differentiating, I want to express that radical with a rational exponent. So the square root of a quantity is the same thing as taking that quantity, raising it to the 1/2 power. So let's just rewrite this just a little bit. No calculus involved. We got f of x is equal to x times 2x minus 1 to the 1/2 power. All right, that way we can use our chain rule and find the derivative of what I'm going to consider the second function. So f prime of x is going to be equal to the first function, which is x, times the derivative of the second. So the derivative of 2x minus 1 to the 1/2 power, we have to use the chain rule there. So bring the 1/2 down. So we got 1/2, rewrite the inside, decrease the power by 1. So 1/2 minus 1 is a negative 1/2. And then take the derivative of the inside, which would just be 2. All right, and now we have to take the second function and multiply it by the derivative of the first. So now I take plus 2x minus 1 to the 1/2 times the derivative of x with respect to x, which is just 1. All right, from here, we just want to write this with common denominator. So if we just clean it up just a little bit, that negative 1/2 power, let's bring that and take it to the bottom using the negative exponent rule. The 2 is already down there. This 2 here is already down there. And so in the numerator, I'll have x. In the denominator, I'll have, let's go ahead and rewrite that with the square root. You don't have to. You can keep it written as to the 1/2 power. It's up to you. But once you bring it down to the denominator, that negative 1/2 becomes positive using that negative exponent rule. And so this will be 2x minus 1 inside that square root. And then over here, plus 2x minus 1. Now that's over 1. And so now if I want to combine these with a common denominator, the LCD, since this denominator is a 1, the LCD is simply the square root of 2x minus 1. And so I don't have to multiply anything to the first term. I just need to multiply that square root of 2x minus 1 in the second term. Remember, do it top and bottom so that you're not changing the value of that term. Now we'll have everything over the same denominator, which is the square root of 2x minus 1. Over here, we did not do anything to this term, so that just stays an x. Over here, we have to multiply square root of 2x minus 1 times itself. So the square root of 2x minus 1 squared is just 2x minus 1. Now if we scroll down just a little bit more, we can combine our common x terms in our numerator, and we'll have f prime of x is going to be equal to 3x minus 1 over the square root of 2x minus 1. Booyah!